Dial indicator usage. Although there are many uses for the dial indicator measurement tool today, we will be looking at three specific measurements that are common in automotive field. This video will briefly address the backlash measurements between a differential ring and pinion gear, end play of a speed gear on a manual transaxle input shaft, and run out on a manual transmission input shaft. Backlash measurements. The V-shaped side of the magnetic base will be used to secure the base to the differential housing, making sure the base is secure and doesn't wobble or move. The articulating arm is loosened to provide manipulation in order to set the dial indicator in the proper position to make the proper backlash measurement. Care is taken to add preload to the setup. The scale and bezel are now rotated to zero the needle. The tilting thumb screw is used to fine-tune the needle position. The needle has been aligned with the zero line. However, from this angle, it doesn't look perfectly on zero. Now the ring gear must be carefully moved back and forth. This will move the dial plunger, and the amount of movement will be measured on the dial indicator. Look carefully because the ring gear is only moving 6 to 7 thousandths of an inch. There are two key setup points to make. The gap in the plunger at the top of the dial indicator was done on purpose. This is the preload value, which ensures measurement not only in a positive direction, but also measurement in a negative direction. The second point to make has to do with the revolution counter. Since the expected measured value was less than 100 thousandths of an inch, there's no need to zero or be concerned about the position of the revolution counter. Measuring runout. This manual transaxle input shaft is resting between two precision machined V-blocks. I use a little trick by using the magnetic base to stick to the workbench and the V-block at the same time. Next, I manipulate the articulating arm to preload the dial indicator to measure the runout on the center machined bearing surface. I apply slight downward pressure on the shaft with one finger while rotating the shaft with the other hand while observing the movement on the dial indicator. To aid in the measurement, I will rotate the bezel on the scale to align the needle with a whole number. Notice that I did not zero the needle, but instead I aligned it with the 40 thousandths of an inch line. I did this for simplicity. Since I'm expecting the needle to move between 0 and 2 thousandths of an inch, it was quicker to rotate the scale a small amount. After aligning the needle, I will raise and lower the plunger a few times to make sure the needle stays in alignment. This is done to ensure accuracy. Now, I can make the measurement one more time to verify the previous reading. Gear end play. Third gear and the synchronizer hub have been installed onto this input shaft. The shaft is being held by the vise using rubberized soft jaws. The dial indicator has been set up using the magnetic base and articulating arm. Since the gear will move straight up and down on the shaft, the dial indicator has been set up to be in alignment with the direction of gear movement. Notice that I'm not able to get the dial perfectly straight up and down to align with the gear movement. A slight angle is acceptable as long as it is not excessive. The tip of the plunger is rounded and placed on the face of the gear. Then, with two hands, the gear is evenly moved up and down while observing the dial movement. I make the measurement a minimum of 3 times. If I get the same reading 3 times in a row, the measurement is good. This gear moves between 7 and 7.5 thousandths of an inch. This measurement is acceptable and can now be compared to specifications.